Hello everyone and welcome back. I am Mr. Cobalt and today we are going to be talking about electrolytes and non-electrolytes. Um, so what are electrolytes? Electrolytes are substances that when you dissolve them in water, they form a solution that will conduct electricity. And the reason why they conduct electricity is because when they dissolve, these substances form charged particles. So either they're going to be ionic substances like salt. So when you throw salt in water, the positive sodium ion and the negative chloride ion will separate, and then the charges will be able to move around. And one of the things that you need in order to have conduction of electricity is you have to have free moving charged particles. So when NaCl is in the solid form, those ions are locked into place pretty strongly, and so they're not gonna move around. So there's no electrical conductivity in a solid salt crystal. But when you throw it in water and the water pulls the ions apart, and now the negative and positive ions can move around, now you have a solution that can conduct electricity. And so anything that really can come apart and form ions, or maybe the ions are already there, but they can come apart and be able to move, then you've got an electrolyte. So lots of salts. Salts are charged ions, so if they can dissolve in water, that will form an electrolyte solution. There are two different kinds of electrolytes. There are strong electrolytes and there are weak electrolytes. So a strong electrolyte is where the electrolyte will dissociate completely into ions when dissolved in water. So 100% dissociation. So this is a one-way equation. So if I throw my salt into the water, then it's just going to go in this direction. So completely, if I have enough water, then the salt is going to completely dissociate into the ions, and I'm not going to have anything left with the salt, assuming I have enough water to dissolve all the salt. So that would be an example of a strong electrolyte. So again, strong is 100% dissociation. Weak electrolytes are where you dissociate a little bit in water, not 100% dissociation. In fact, it's going to be very, very, very little dissociation in water. And so that would be a weak electrolyte. So the difference between a weak electrolyte and a strong electrolyte is that the strong will dissociate 100%, completely dissociates in water. A weak electrolyte dissociate a tiny bit in water. So a couple of examples. You can also talk about strong acids and weak acids as examples of strong and weak electrolytes. When we talk about acids, though, we don't use the word dissociate in water. We only use that word when we're talking about ions, because with regard to the ions, you already have charged particles in your compound. So we say dissociate because they're pulling apart. We're not dissociating ions in strong acids and bases, or strong and weak acids, is because the acids themselves are molecules. They're not ionic compounds. So before you throw them in water, they are molecular substances. But when you throw them in water, we say the word ionize, because they become ions when they're in the water. So if the hydrogen separates from the rest of the molecule, then the hydrogen is a positive charge and the rest of the molecule will be negative charge. So they ionize, they become ions when you throw them in water. So we talk about ionizing. So a strong acid is a substance that will ionize completely in water. So 100% dissociates. So again, the arrow is in one direction. So it goes from HCl, throw it in water, and it all dissociates into H plus and Cl minus. So it ionizes into these ions, and you'll have 0 left over of the HCl. None of this will be left, and all of it will be in this form. So it's a strong acid or strong electrolyte. So this is a good example of a strong electrolyte as well. Because when this dissociates in the ions, now you have free moving ions, and then that will conduct electricity. Your weak acids, again, those weak acids are going to ionize a little bit in water, right? So very, very little bit of it will dissolve in water. So what you get is this equilibrium. So some of the acid, so this is acetic acid. So here's my acidic hydrogen, that's going to come off. And so I get the H plus, and then what's left over is my negative ion. And so here, there you have a double arrow, one going in the forward direction, one going in the reverse direction. And so what that indicates is that for a weak acid or a weak electrolyte, there is an equilibrium where some of the acid is ionizing into H plus and the negative ion, and some of this is actually going to be coming together and going in this direction. Actually, most of the substance is going to be in this form in the water. So most of it is going to stay in this form. It's not going to ionize. And a little tiny bit of it will be in this form here. So so that's what the double arrow means here. So this is an example of a weak acid. So a weak acid is an example of a weak electrolyte, because very little of it is going to dissociate or ionize into ions. And so it might conduct electricity a little bit. Okay, what about non-electrolytes? Non-electrolytes are those substances that when they dissolve in water, the solution does not conduct electricity. So you're not forming any ions whatsoever. And sugar would be a good example, where, or any molecule that doesn't ionize in the water. So sugar is a good example. You dissolve sugar, the molecules will dissolve in water, but the molecules do not have charge. So there's no conduction of electricity when you have non-electrolytes. So that would be an example of a non-electrolyte. So I hope this is helpful in understanding the differences between electrolytes and non-electrolytes, and the difference between strong and weak acids or strong and weak electrolytes. Thanks for joining me, and if you like this video, please like the video, share the video with your friends, subscribe to the channel, and make a comment in the comment section. Let me know what you think, and be sure to ring the notification bell so that way you get notified for any new videos that I put out. Thanks for joining me, and I'll see you next time.